Hi folks, so this is question 5. So we have a sphere here and then we have kind of two cones stuck to each other that are the same inside it. So you have to prove that the volume of the space inside. So obviously the space that's remaining will be the volume of the sphere, take away the volume of two cones which are the same. So volume of sphere, and you can get these from the log tables. It's 4 over 3 pi r cubed, and then the volume of a cone is 1 over 3 pi r squared h. So we have to use both of those formula then. What you need to notice here as well is that, so that's the radius from there to the outside, but that straight up there, that's also the radius. So what you need to see is that r of the radius of the sphere is the same thing as the height of one of the cones. So r equals h here really. So we could just call both of them r, or both of them h if you wanted. So volume of sphere then, so the space then is going to be 1 take away the other. So 4 over 3 pi r cubed take away, and it's not just one of these cones, it's two of them, because remember there's two of them inside the sphere. So we're going to multiply, if you multiply that formula by 2, it would just be 2 over 3 pi r squared, and then h, I'm just going to put in an r instead of h, because it's because remember we said r is the same thing as h, as the height of one of the cones is the same thing as the radius of the sphere. So you can see there that that's going to be 4 over 3 pi r cubed minus 2 over 3 pi r, and then r squared times r is cubed as well. So we have the same, they're like terms really, we have the same thing there. So therefore you can just subtract the two numbers. So we'll get 2 over 3 pi r cubed. So we have to prove that the volume of the remaining space inside the sphere is exactly half of the total volume of the sphere. So you can see clearly it is. So when we subtracted them, so that's the space, and then the actual the actual volume of the sphere is 4 over 3 pi r cubed. So half of that would be 2 over 3 pi r cubed. So that's the half the sphere then. So that's half the sphere there that we worked out, and we already worked out the space that's left inside. So half the sphere is equal to the same thing as the space that's left. So that's that proved. Right, so for the second part, all we need to do is we need to let that formula 2 over 3 pi r cubed be equal to what it is, so 686 over 3 pi. So we know from the first part that this is actually the combined volume of the two cones. It's just of one of the cones times by 2, and we're still letting r be the same thing as h. So you'll see then things are going to cancel out, so the pi's will cancel out, but also the 3 on the bottom. There's a 3 on the bottom on both sides, and when you've got that, you can just let them cancel out. So what we're getting is 2 r cubed is equal to 686. I can divide that by 2 easily enough. It's going to be 343. So we're getting r cubed is equal to 343, and 343 is actually a cube number, so r is actually equal to 7, because 7 cubed is 343. So that's the answer. R is 7. Right, so for part B then, So a van leaves at 9 o'clock and it travels at 60 kilometers an hour, and then basically an hour and 45 minutes later another van takes off, but that van is traveling faster. So you imagine a van leaves somewhere and then another van leaves after, but that van is traveling faster. Well, the van that's traveling faster is going to catch up on it. They both arrive at the same time, so it's just that the van A takes a lot longer. So we'll call them van A and van B. So with speed, distance, time questions, I like to always just try and write down the distance, the speed and the time. So D, S and T as you're given them, and then kind of figure out what you need or what they're asking you for. So the speed anyway for the first van is going to be 60 kilometers per hour, and the speed for the second van is 95 kilometers per hour. We don't really know the time, that's what we're trying to find out, but we'll just let the time be T for van 1. Actually I'm going to let the T be the time for van 2, and for van 1 then the time would have to be T plus an extra 1 hour and 45 minutes, so we'll say 105 minutes. So T plus 105 basically is the time. Distance then, the distance that they're traveling, well, they're both going to the same destination, they end up in the same destination, so the distance is the same. So we'll just say it's D and D here, so distance is the same. We know from so the DST, you should know that distance is speed multiplied by time. So therefore if the distance is the same in both of them, so distance for van A has to be the same as distance for van B, so therefore the speed multiplied by the time has to be the same in both of them. So for this one, 60 multiplied by T plus 105. Actually, I just noticed now I've given those two things in different units someday, so I might just call that 1.45 instead. Or sorry, 1.75, because it's 1.75 hours. So we're putting everything in hours then, and that has to be equal to speed multiplied by time, so 95 multiplied by T. So 95 multiplied by T would just be 95T. Then we have to multiply the 60 by both of these, so 60T plus 60 multiplied by 1.75, and that's 105. So you just move everything to the right side, so we can move the 60T over to the right hand side and it becomes minus, so we're left with 35T is equal to 105, and then you're just going to divide across by 35, so that works out nicely to be 3. And remember, it's in T, so it's in hours. We left everything in hours, so it's hours. So T is 3 hours. So think about then if the so remember, van A left at 9 o'clock, and then an hour and 45 minutes later, from the hour and 45 minutes later, it took another 3 hours, because we worked out that T was 3 hours. So it'll be 3 hours plus 1 hour 45. So that's 4 hours 45. So 4 hours 45 minutes after 9 o'clock would be 1:45. So 9, 10, 11, 12, 1, and then 45 minutes. So 13 45. So that's our final answer then, 145 or 1345. And that's all for that question.